So I don't know if you had a chance to see my announcement that I put in Eagle Online yesterday. But the way that I'm going to work this week is that because we finished all of our new material, right? We're done with new material. And this week's sort of like a dead week in terms of obviously there's no new material. You're taking test 5, which is due tomorrow. And then you have the final, which is due next week. You can start taking the final on Tuesday of next week. Tuesday and Wednesday are your 2 days that you have to take it. We have a designated time on Tuesday in the Foundational Math Center at 8 a.m. for those of you who are in the Flathead area. If that doesn't work for you, that's fine. You can take it at other times on Tuesday and Wednesday, but the tests only start on the even hours because you need 2 hours to complete it. So the exams will start at 8 a.m., 10 a.m., 12 p.m., 2 p.m., and 4 p.m. 4 p.m. is the last time on both Tuesday and Wednesday that you can take the final of next week. For those of you who are taking it on the Libby campus, obviously you need to schedule that time with the front desk there, and Melissa and Brittany, obviously you need to coordinate your what am I trying to say? Your proctoring where you are at. So again, my focus for today and Thursday is to just answer questions as they pertain to Unit 5 and to the final. Obviously, today is a better day to ask Unit 5 questions since the test is due tomorrow. The review for the final exam is posted, so you should be able to start working on that. But the final won't release until next week when obviously you can start taking it. So yeah, the review looks like it released on the 1st. So all of that is to say, what questions do you have?
I was struggling with the homework from yesterday as far as 5F, and my questions were, I guess number 4, 6, 7, and 8 are the ones I was struggling with.
Okay, so just so I can kind of get a list of everything.
Okay.
Do other people have questions about the 5F homework?
I just have a hard time figuring out when to use the log function. I think I'm starting to get it. It's just kind of like when you're trying to undo the exponent, right?
Yeah, so if you're given a formula that's in exponential form and the variable is in the exponent, that's when you're going to be using logs or natural logs.
Okay, so there has to be a variable in there.
Yeah. And
Okay.
the natural log only applies when you have base E, right?
Mm-hmm.
So
okay, that makes more sense because I was really struggling to figure out when to actually put log in. I understand how to do it, but
yes. Yeah, so it's if say we have let's say we have, I don't know, 3 to the x equals 9. We'll just keep it really easy. Then what we would do is we would say log base 3 of 9 equals x. That's how we would solve for x, right? And to enter this into our calculator, we would have to do log of 9 divided by log of 3 in order to solve for that, which we would get x equals 2 because 3 squared is equal to 2. And then if the equation is in logarithmic form, then we have to use exponential. So if we have, say, log of x plus 2 equals, no, that's going to be way too hard. Log of x plus 2 equals 1. In order to solve this, remember that we've got this little 10 here that we assume if it's just log on its own. So we would have to switch this into exponential form. So we would say 10 to the 1st equals x plus 2. So that we would simplify the exponent, 10 to the first is 10. And we would subtract 2 from both sides. 10 minus 2 is 8. Therefore, x equals 8. So that's one where they gave it to you in logarithmic form. You need to switch it into exponential form in order to be able to solve it. Okay, so questions from 5F, so we can go through those. Any other questions that we want to put on the list?
I think using base E would be my question.
Okay,
When to use it?
so base E, one of the things like when we talk about the when we talk about the what am I trying to say? My brain just like is going along and stopped. The oh my gosh. The continuous compounding. There we go. So like if we think about the quiz that we just had and those problems that had to do with continuous compounding, that word continuous indicates that we're going to have base E, right? If so, or they'll give you the formula. So like number 6 from the homework gave us the formula that it said P of T equals P times E to the KT. Now, K and R are used interchangeably here. The rate and K are kind of the same thing. And so with this, we know that we have to use that base E. And this base E is telling us that it's compounded continuously.
No, don't tell me to get up and stretch. How dare you?
Carolyn, you're still your mic.
Sorry.
No, don't worry about it. I just want to let you know. So the E is again telling us compounded continuously. So with number 6, the first part, because this kind of leads into all of this. The first part said, what is the exponential growth function in terms of P and 0.04? Because it's telling us that it's compounded continuously at 4% per year. So all they want us to do there is to write the formula with base P, or not base P, but with P, meaning we don't know how much is being invested, but we've got P times E to the 0.04 T. So this formula here sets us up to be able to put any initial investment in. And so the second part says, what if 2,000 is invested, what is the balance after 8 years? So what they're telling us in part B is now let P equal 2,000. So if we put that in, we'll have P of T equals 2,000 times E to the 0.04. And now they want the balance after 8 years. So we would plug in 8 for T. Obviously, at this point, we're just going to calculate that. So again, you know, one of the places that we make errors is in how we're inputting this into our calculator. So when we're plugging this in, we're going to do 2,000 times, and then we have, we got to do the second ln key to get e to the x. And then in that exponent, we're going to do 0.04 times 8, right? So we can do all of this as one, what am I trying to say, as one calculation. So then we're going to enter that and we get 2,754 and it's 255. And so I'm just going to do 26 because they're going to want it just to the nearest cent. Remember, cent is 2 decimal places. And then the last part of that question says, how long will it take for the investment of 2,000 to double itself? So when we're saying how long for it to double itself, if we double 2000, we're doing 2 times 2000, which is going to be 4000, which means we're now plugging 4000 in for P of T. So we're looking for the time, that whole how long means find T. So using our formula, we're going to have 4000 equals 2000 times e to the 0.04 T, right? So what they're telling us is that, okay, we know that we're doing that initial investment of 2000. So that's our P value. And when is it going to be double that? So that's our P of T value. So from this point, we're going to divide both sides by 2000. 4000 divided by 2000 is be 2. And 2 equals e to the 0.04 T. So I get the question all the time. Again, as we've already said, when do we use E? When do we use log? When do we use natural log? So this is a situation where we have an exponential equation. We know it's an exponential equation because it's taking E and raising it to that 0.04 T exponent. So we need to undo that in order to get to that exponent. And in order to get to that exponent, we need to take the natural log of both sides. We're taking the natural log of both sides because we have base E. So I know I've kind of run out of room, but I don't want to go to the next page. So I'm going to just move up here. So I'm going to take the natural log of both sides, which means the natural log of 2 equals the natural log of E to the 0.04 T. Remember, we have this thing called the power rule that once we take the log, we can take that exponent and bring it down in front. So now we have the natural log of 2 equals 0.04 T times the natural log of E. Remember, the natural log of E is equal to 1, so I can drop that off. So I have the natural log of 2 equals 0.04 T. Now solving for T, we'll divide both sides by 0.04. You'll notice that I did not calculate what natural log of 2 was, right? I didn't first figure out what that was and round that number off. Because remember, I've said this multiple times, you don't want to do any intermittent rounding because that will cause our values to be off. So from here, I'm going to do natural log of 2 divided by 0.04. And that is going to give me T equals 17.32867951, and the instructions say round to the nearest 10th of the year. Therefore, we're going to get T is approximately equal to 7.3. So questions about that? That was number 6, excuse me, from your homework from 5F. Okay, so one of the questions that was asked in the chat was the problem about sounds I struggle with. So if we think about from your homework, that would have been problem number 1. And when I talk about the proper homework, I'm talking about 5F. It says, what is the loudness in decibels of a sound 10 billion times as loud as the softest audible sound? So and some of you had like 100 billion times. Not all of you had 10 billion times, but the process is still going to be similar. 10 billion times as loud as softest audible sound. So obviously, in order to be able to answer this, you have to look at your notebook pages because that's the only place other than, I mean, you can say, help me solve this, and it'll give you some of that information. But if we go back to 5F, and we look at the decibel problem, right? So this is application number 5. We know that 10 to the negative 12 watts per meter squared is the softest audible sound. So if we want to do 10 billion times that, so we're going to do 10 billion times 10 to the negative 12. Well, we need to simplify the 10 billion portion. Billion is 10 to the 9th. Therefore, if I have 10 billion, that's 10 times 10 to the 9th, which we would reduce to 10 to the 10th. Remember, when you're multiplying with exponents, 10 times 10 to the 9th, those are the same bases. And if we think about 10 has a exponent of 1 there that we need to remember is there. And therefore, when we're multiplying those, we're going to rewrite the base, add the exponents, meaning 1 plus 9 is going to be 10. So we're going to do 10 to the 10th times 10 to the negative 12th. Again, that same idea holds where we rewrite our base and add our exponents. So this is going to give us 10 to the negative second. But that doesn't actually give us the loudness, right? What is the loudness? So in our homework, or in our notebook, excuse me, we have the formula that says loudness is equal to 10 times the log of the intensity over I sub 0, which is just 10 to the negative 12. So this is what we call the intensity, because we're saying 10 times that 10 to the negative 12. So we have simplified our I first. So going down to our formula, we're going to do L equals 10 times the log of 10 to the negative second over 10 to the negative 12. Continuing to simplify. If you don't want to simplify your powers of 10 inside, you could just enter this whole thing into your calculator. I would argue it helps to simplify. Remember, when we're dealing with division, we're going to take our denominator exponent and we're going to subtract it. So we're subtracting negative 12, which becomes plus 12. So 10 to the negative second plus 12 is going to be 10 to the 10th. And now we can plug this into our calculator. So I'm going to do 10 times the log of 10 to the 10th, right? So you want to make sure that you get all of that inside. For the newer calculators, make sure you unpress the, or you press the right arrow key to come out of that exponent when you're adding in that last parenthesis. Obviously, in this calculator, it doesn't do that. But if you are using one of the newer ones, it will have it still stay up there. And so you want to make sure you press the right answer key, right arrow key, this arrow key right here, to drop it out. And so then we simplify this, we get that the loudness is equal to 100 decibels. So, questions about that problem? Okay. So continuing with the homework questions that were asked from 5F, we're going to look at number 7. And so number 7 says, and again, you all have similar similar explanations or problem setups, but you're not necessarily going to have the same numbers. So this one says the decay rate of a certain chemical is 9.3% per year. What is the half-life? Oops. Actually make that a question mark. And says use the exponential decay model where use the exponential decay model P of T equals P sub 0 times e to the negative KT, where K is the decay rate and P sub 0 is the original amount of the chemical. So I know they don't give us an original amount, which means you can use whatever you want. In this case, we can just use 1 for P sub 0 because they're not giving us an amount. So we're going to say P of T equals 1 times e to the negative KT. Well, remember 9.3 is going to be our K value, 9.3%, which we're going to put as 0.093. Now we're trying to say, what is the half-life? So the half-life is how long it takes for there to be half as much as the starting amount. And so if we choose 1 for P sub 0, remember that's our initial amount, then we're saying, when will P of T equal 0.5? Because 0.5 is half of 1. So setting up our equation, we're going to do 0.5 equals 1 times e to the negative 0.093 t. The nice thing about choosing 1 is 1 times the amount doesn't change the value. So we can simplify this to 0.5 equals e to the negative 0.093 t. So what should I do from here?
Take the natural log of 0.5 and divide it by the natural log of, no, take the natural log of 0.5 and divide it by 0.093 negative.
So we need to take the natural log of both sides.
But the natural log of e cancels, right?
Yes, but it's important to still write out this step because we have to remind ourselves this is a rule as to why we can bring this down in front, because on some of our problems, we don't get the natural log of e, right? We take the log of both sides and it's like the log of 2 on the right-hand side, which means it's not just going to drop out. So you don't want to jump a step. You want to go through the same steps so that you're in the habit of going through those steps, because there will be times when you have to divide both sides by whatever the log is of that, if your base is not e. So this is going to take that negative 0.093 t from the exponent and bring it down. And yes, that is still times the natural log of e, which you're right, it does drop out. Oops. So from here, we're going to divide both sides by negative 0.093. And the natural log 0.5 divided by negative 0.093. And we get t is equal to 7.45 0.319549, and it says round to the nearest integer. So some of these are, so normal rounding is going to say 7 years, but technically if we just did 7 years, it's not going to be the actual half life, meaning you would at 7-year point, you would still have a little bit more than half. And so 8 years would be appropriate here as well. It looks like in the homework, they had you round down, which I'm surprised, because usually when they have these types of problems, even though they have the decimal portion that's less than 1, it would have you round up in order to accommodate the fact that you're going over 7 years. But for this problem, they had you keep the amount that's, follow normal rounding rules. On the exam, if you were to round up and give me an explanation as to why you rounded up, if you had said, like, I went with 8 years because if you just went with 7, you're not going to actually have half this amount, I would give you the points for that, because again, you're understanding what's actually happening and you're giving me an explanation for your answer. So questions about that problem? So number 8 kind of is related to this one, because it's still concerning the half-life, but now it's telling us that the half-life is a certain number of years and they want us to find the rate. So your steps are going to be the same, except we're going to be looking for K instead of T. So here's what that's going to look like. So the number 8 that I have in front of me says the half-life of a certain chemical is 4 years. What is its decay rate? And again, they don't give you an amount to start with, okay? They don't give you that starting amount. They tell you to use the formula P of T equals P sub 0 times E to the negative KT, right? And so K is the rate, and that's what we're ultimately solving for. Because they don't give you the amount that you need to start with, again, I'm just going to say, let's let P sub 0 equal 1. Let's make our life easier. And since we're looking for the half-life, that means we're looking for when it's equal to 0.5, because again, 0.5 is half of 1. So if we plug in the information that we have 0.5 is equal to 1 times E to the negative K times 4, because it takes 4 years in order to get to that 0.5 amount. So simplifying this, I do encourage to rewrite this so that the 4 is in front of the K. The only reason why I say that is because it can be confusing to have your variable on the end, right? So instead of it being negative K times 4, it's going to be negative 4K. And that's helpful to make sure that we divide both sides by the negative once we get down to that point. Like I said in the last one, it's helpful to use 1 because 1 times E is just E to the negative 4K, right? That's the beauty of using 1. So simplifying, we'll have 0.5 equals E to the negative 4K. And then just like the last problem, we want to take the natural log of both sides, right? So taking the natural log of both sides, we'll have ln of 0.5 equals ln of E to the negative 4K. Again, using that power rule, we can bring that exponent down in front. So we get the natural log of 0.5 equals negative 4K times the natural log of E. Because the natural log of E is equal to 1, we can drop that off. And we get the natural log of 0.5 is equal to -4k. So at this point, again, we're just trying to solve for that k. So we're going to divide both sides by -4. So if we pull up our calculator, we're going to say the natural log of 0.5 divided by -4. And it's going to give us this decimal equivalency, which is 0.1732867951. Now, this is the decimal equivalency to the percent. So in order to actually report it as a percent, we need to move that decimal place 2 places to the right, which gives us 17.32867951. And it says round to the nearest integer. So k is approximately equal to 17%. So what I hope you see is that once you establish your equation, the steps to solve it are pretty similar each time, right? If you have E and you have your variable and your exponent, you're going to take the natural log of both sides, right? That's just going to be part of your process every single time. Next question. What else do we want to talk about?
I just have a question on number 8. I'm following the whole process. It makes sense, but I keep getting the wrong answer. And I know I usually mess up somewhere in my calculations, but mine's a half-life of 5. So basically I have log 0.05 or 0.5 divided by -5. And I put that in there and I keep getting 0.599 and the answer was 14%. So I'm trying to figure out where I'm coming wrong.
Did you end your parenthesis after ln of 0.5?
I'll try that one more time and see. I'll let you know. Hold on. Yes, I did.
Did you put in the negative sign for 5?
Correct. Yep. I've got it just like my calculator says, exact same thing yours does. Exactly to the T.
And you're not getting 0.1386?
Oh, I'm putting 0. Okay, I see what I did. Instead of putting 0.5, I put 0.05.
There you go.
That's what, yep. Okay, I got it. Thank you.
You're welcome. So again, on your test, make sure you write out everything you're putting into your calculator, because then I can see where there can be an error, right? Like I will know that you understand the process. It's a calculator error, which earns you more points, right? If you get the question wrong, worst case scenario, but it earns you more credit than if you're just writing an answer and I have no idea if you understand what the process is, right? That just tells me you're guessing, right? So make sure that you are writing down everything that you're putting into that calculator, everything that you're doing to simplify that problem, so I know you understand the process.
Is this just give me 12 questions again for that exam or for the test?
I think it's 11. Let me look.
Okay, Erin, I have my question now.
Yes, let's
So this is what we were emailing about yesterday.
yes.
So it kind of is between question 7 and 8
From 5F or from something else?
from the review.
Oh, from the review. Okay.
Yeah. So
Hold on one second.
in question 7 is where I was asking you, that was the one where we find the APY where we use 100.
All right, I'm pulling up the review. It might not have the exact same numbers as you, but okay.
Well, it's not that it doesn't have anything to do with the numbers, but
Oh wait, I'm looking at the wrong thing. Hold on one second.
so it's the one where you find the APY
Okay.
on number number 7 on the review for me.
Okay. So it says find the annual percentage yield for the following situation. Okay. So,
Well, I know how to find it. Just my question was, so you minus the answer you get from this when you're finding the APY by 100 and then divide it by that 100, right?
so are you choosing 100 as your initial investment amount?
Yes.
Then yes. Yes. So I mean, I think this is a good one for all of us to review. So it says a bank offers an APR of 6.9% compounded daily. And you might not get compounded daily, right? You might get compounded monthly or whatever, but it wants us to find the APY. And they don't tell you any information about like how much money you're investing. So what you want to do is you need to choose that amount, right? And so you want to choose something that's easy to deal with. And so this is coming off of our work that we did in 5B. Okay, and so if we're looking at this, we want to first find the amount that it happens after 1 year. So when you're finding the APY, it's always the comparison between your initial amount and what your balance is after a year. So in order to calculate your account balance, we have A equals P times 1 plus R over N to the NT. So we know that R is equal to 6.9%, which we're going to plug in as 0.069. And because it's telling us compounded daily, that means N is going to be 365, right? That compounded daily tells us this. So if we plug this value in, we get A equals P times 1 plus 0.069 divided by 365 to the 365 times 1, because we're doing it for 1 year. Because they don't give us an initial investment amount, my suggestion is to use 100, or you can use 1. It does not matter. You just need to establish what that initial investment is, and then you can move on from there. So we're going to plug in $100 because that's what we're going to use as our initial investment.
Oh, I got her.
Hey, Melissa, will you mute yourself?
Oh, sorry.
So plugging this in, again, we can put all of this in as one calculation. So we're going to do 100 times, and then we've got 1 plus 0.069 divided by 365 and our parenthesis. Then we're going to have to do the caret key in order to get the exponent. And in here, we're going to do 365 times 1. Yes, I know you don't have to do the 365 times 1. You can just put the 365 in. But again, practicing those steps of knowing what we're doing so that if they're asking what's your account balance after 10 years, you would do 365 times 10 instead of 365 times 1. So finishing this, we're going to press enter, and then we get an account balance of 107.142922, which we will round to the nearest penny. So 107.14. So in order to calculate APY, I know some of you found a random formula on the internet to calculate APY based upon your APR. Again, that's not a formula that I teach because I think it's another thing that you have to try to memorize when you already have to know the account balance formula. And therefore, you can build off of that account balance formula in order to come up with the APY. So in your notebook, I tell you that the APY is the interest earned in 1 year divided by the principal. So in order to calculate the interest earned, you're going to take your account balance. Why am I writing 147? We want to take 107.14, and we're going to subtract the initial investment. And then we'll divide by the initial investment. So if you're looking for, well, how would I write this out in order to try to think about this in terms of a formula that I could remember the process, we would think of this as being the APY is equal to our account balance minus the principal divided by the principal. So if you choose a principal of $1, then you would be dividing by 1 every time. If you choose a principal of $100, then you're dividing by 100 each time. So subtracting these, I'm going to do 107 minus 100 is going to be 7.14 divided by 100 gives us 0.0714, but they're going to want you to enter this as a percent. So we'll multiply by 100. And this gives us 7.14%. And they will say round to 2 decimal places as needed. So I'm going to have 7.14% as my answer.
Oh, okay, so that was the first part of my question.
Yes.
And now I feel like on number 8, on the second part where it says of the total amount paid, what percent is paid for the principal and what percent is paid toward the interest?
Right.
We also find the APY, right?
You're not finding the APY there.
Okay, but we do the same steps on that, don't we?
Well, you do similar steps, but instead of comparing it to the principal, you're comparing it to the total amount paid. Because we're saying what percentage of that total amount paid went to the principal and what amount went to the interest. So if we look at that problem, number 8, it says consider a home mortgage of $225,000 at a fixed APR of 12% for 20 years. Part A says calculate the monthly payment. Which means we need to pull out our giant payment formula, right? This came from 5C. So our payment formula is P times the APR over N divided by 1 minus 1 plus the APR over N to the negative NT. So our principal amount is going to be 225,000. Our APR is 12%, which we're going to plug in as 0.12. Our N is always 12 for mortgages or credit card balances. And then T is going to be 20 years. So if we write out what we need to put into our calculator, and again, this is an example of tell me what you would be putting in. So we're going to do 225,000 times 0.12 over 12 divided by 1 minus 1 plus 0.12 over 12 to the negative 12 times 20. So there's obviously places where we can make mistakes entering this. We need to make sure that we're grouping things. So you're going to want to make sure you have parentheses around your numerator. And then you're going to want to make sure you have parentheses around this exponent here. So if we plug this in, we're going to have 225,000 times 0.12 divided by 12. End our parenthesis. Then we can do division. And then we're going to do 1 minus 1 plus 0.12 divided by 12. End that parenthesis. Then we'll do our caret key, new parenthesis, -12 times 20. End parenthesis, end parenthesis. Calculating that gives us a payment of $2,477.44. So with these problems, you have to make sure that you are, obviously each answer depends on what you have before, right? So part B says determine the total amount paid over the loan. So in order to come up with the total amount paid over the loan, we're taking $2,477.44. We're multiplying it by 12 months because there's 12 months in a year, and then times 20 because again, we're paying this for 20 years. So this gives us a total of $594,585.60. So that would be the total amount we paid over the life of the loan. So the last step is where we get to your question, Melissa, right? And your question is, how do we calculate the percent paid towards the principal and the percent paid towards the interest? So to calculate the percent paid towards the principal, we're going to take the total payment minus the principal divided by the total payment. And then times 100 because we have to convert it to a percent. Because we're saying what amount of the total payment went to that principal, that's why we're dividing by the total payment. We're not asking for how much did our investment grow by. We're dealing with an actual payment amount. So yes, there is sort of the same calculation that's happening here, but it has to do with the wording and what they're actually asking for. So if we plug this in, we're going to do 595,585.60 minus the 225,000 because that was our initial borrowing amount, divided by the 594,585.60. And then obviously, like I said, we would multiply by 100, and that's just to convert it to a percent. So if we do this all as one calculation, we need to put the numerator in parentheses to make sure that we do that subtraction first. So 594,585.60 minus 225,000 divided by 594,585.60. And then we want to multiply this by 100. And we get 62.15851,847. Now, oh shoot, I gotta enter. I need to see. Hold on, give me 1 second, really fast.
Okay, thank you. So I think I had it confused because on the other one, you do it the other way, and on that one. So they're two totally different equations.
Yes, they're completely different questions. So it says to round to the nearest 10th. So we're going to have 62.2% would be towards the principal. So then to calculate the percent, paid towards interest, don't go through this whole thing again. Remember, 100% of that amount paid over the life of the loan was broken up to either principal or interest. So all you have to do for this second part is subtract that amount off of 100. And so if we subtract those, we get that we paid 37.8% in interest. So again, when you're putting this in, make sure that you're paying attention to where those boxes are, right? Because the first box will say something to do with blank percent paid towards, and for me, it says principal. So I'm going to put that amount in. And then the second box is your amount paid towards interest. And so you only need to calculate one in order to then subtract that amount from 100 to get the second one. Don't go through that whole process again to try to figure out what percent was principal, because, or excuse me, what percent was interest. Like it's your, wait, hold on. Total payment minus principal. Okay, so sorry, I'm going through this and I realized a mistake. Does anybody else see a mistake with what I've laid out for part C? I'm going to give you a hint. If I take the total payment and I subtract the principal, what would that difference represent?
The interest.
Right. So,
Yeah, it's backwards.
yes. So we're going to do a little correction here. So that means that the total amount paid towards interest is your total payment minus your principal, which is gonna, it's still all the same process. You just want to remember that this amount, oops, this amount represents your interest. So therefore, if we go down here, the total amount paid towards the principal, actually, let me write it in a different color so we remember that I made a mistake, is that 100% minus the 62.2%. I'm sorry for leading you astray. The process is still the same. You just want to make sure that you are calculating one to help you calculate the other. The easier one, obviously, is to calculate the amount paid towards interest first, and then subtract that off of the 100% to figure out how much is paid towards the principal. I'm sorry for making a mistake. So questions about that one? I know that at the very end, I threw us all for the loop, but zoom out so we can kind of see the whole thing. More questions? Or did I just completely fry everybody's brains because with my mistake?
Are we going to be given any of these formulas to use on our test for tomorrow or only on the exam?
So for test 5, you've got the formula sheet that you are using that's the same as what's in the back of your notebook. So you'll have that. And then when you take the final exam, we have a formula sheet that is written just for the final.
Okay, thank you.
More questions? Okay, so tomorrow is an optional day. So I'm happy to answer questions tomorrow relating to test 5 or the final exam. So if you want to log in and answer or get questions answered for test 5 before you take test 5, obviously we can use tomorrow as that time. And then Thursday we'll answer questions related to the final. Give me some feedback here, guys. How are we feeling?
I feel good and also not good.
That's fair. I understand that.
I feel a lot better about the log formula.
Okay.
And then the continuous compound, that will say continuous compound, and then you use that. I don't think we had any of those on our review,
Let me see.
or I haven't gotten to them yet.
I'm just gonna click through real fast to see if I can come up with one. So it doesn't look like there is one, but I would encourage you to still look over that problem from your quiz that was the continuous compound one. Just to be prepared, you know? But yes, Melissa, to answer your question, if it is continuous compound, it will say continuous compound.
Okay, sounds good. And I'm not totally done with my review yet, so I might just be messaging you this afternoon again.
That's fine. All right, anything else?
Should we sign up for our test to be proctored now, or should we wait until after this test for the emails to go out about finals?
You can sign up to have it proctored now and then just cancel the appointment if you're worried about like times filling up. Or you can wait, but I mean, the problem with waiting is that, you know how it is, I don't get the exams until Thursday at the very earliest, right? And so if I don't get them Thursday and I don't get them until Friday, and then I have to grade them Friday, I won't be sending emails until Friday afternoon. And then that could be too late to schedule an appointment. So I would encourage you to schedule now, and then you can always cancel afterwards.
Okay, thank you.
Mm-hmm. All right. Well, if there aren't any questions, I mean, if you don't have questions, you don't have to stay. Excuse me. tomorrow obviously is optional. I'll be here. If you have questions about test 5 or the final, log in, ask the questions. And then Thursday is going to be all about the final exam. So tomorrow, if you get a chance after you take your test, I'd encourage you to kind of flip through that final review, look at questions on there, see if you see something that goes, oh God, I totally forgot how to do that. And then we can go over that on Thursday. Because Thursday is our very last class. So your last opportunity to ask questions as a group. Obviously, I will answer your email still, but you know what I mean. The final exam testing is the only thing that's different is that it only starts on the even hour. Other than that, you're going to take it in the FMC. And you know, all of that is going to be the same. One thing I did write about in the announcement is that for the review, you have to record your written work. That is one extra step we make you do for the final review. As much as it frustrates people, the reason for that is that studies show that if you write things down as you're doing them, you remember them better. And so writing out your steps in order to solve those problems is going to help you to remember how to solve those problems. It'll trigger that information when you're going to take the test. So it is a valid reason as to why we're asking you to do that. So for the review, you do need to record your written work, obviously number it, organize it, and you need to scan and upload it. And that is true for students who are also exempt for the final. I wrote in the announcement how you would be exempt from the final. And if you are exempt and you don't complete the review and upload your written work, you will receive a 0. So for your final. So obviously it's important that you do that. So everybody has to do their final review. Everybody has to upload their written work for the final review, even if you're exempt from the final.
Do we need to upload our work for the other reviews as well?
No.
Okay, I was like, man, I missed that part every single
No.
time.
That's why I'm saying this is a different thing, right? Like it's the only time we require it is for the final exam because it is so important. All right. Well, that's all I have. Again, this is all about you and what questions you have. So if you don't have any questions, you're free to go. And maybe I'll see you tomorrow, but I'll see you on Thursday for sure.
Thank you.
You're welcome. Have a good day, everyone.
Is tomorrow required?
No, tomorrow's
like-
optional.
Okay,